Hi, hello everyone. Welcome to my YouTube channel. In today's video, we are going to learn how rolling update deployment strategy is going to work in a Kubernetes through a practical demonstration. First, we will understand what is rolling update and what are all the key features it is going to provide. Then we are going to understand the architecture, how internally it is going to replacing the old version of the application with a new version without affecting the end user. After that, we will briefly go through the manifest file, what image I am using, what are all the service I am going to use in my manifest file for a better understanding. Then we are going to move on to the hands-on demonstration. We are going to apply the manifest file using the kubectl command, and we are going to run the watch command in a background to understand how it is going to updating the old version with a new version. Then we are going to collect the watch command output. Then we are going to analyze the each and every line from how it is going to updating from old version to the new version. And then we are going to compare our watch command output with the architecture, whether internally it is going to working what we expecting or not. By the end of this video, you will have a clear understanding of both theoretical and the practical implementation of a rolling update deployment strategy in Kubernetes. So, without any further delay, let's get started. First thing is, what is rolling update? Actually, you know what is the twist in my YouTube channel? I'm not going to tell the definitions of what is rolling update. At the end of this video, you will only understand just by reading the definition of the what is rolling update. Okay, at the end of the video, I'm going to tell what is rolling update. For now, I'm just skipping this question. The next topic is key features. Rolling update is a default deployment strategy in Kubernetes. If you not specified any deployment strategies, it is going to take it as a rolling update deployment strategies. And then a zero downtime. What it means is end user is not going to face any error pages, whether they may get the old version of the application or a new version, but they will not face any errors in the website. Then gradually pod replacement, it means how it is going to update from old pods to new pods by step. Easy rollback, we can quickly revert to the previous version if the deployment got failed. Then control deployment, here we can put some conditions, at what time it is going to update to the new version, when it is going to come back to the previous version, like those things. We can see max search session and the max unavailability, uh, like these things we can add the features in a rolling update. And then high availability. Now we will understand the architecture of the rolling update. First, what is existing here is there are two pods, load balancer or any service which you created. It is going to routing the traffic to the two pods. This is the version 1. When you use the deployment strategies, how it is going to update from version 1 to version 2. Now I am going to show you. Now I am just creating the one more version 2 for version 2. Now when you applied when you apply the rolling update deployment strategies with a different image name with a different image tag, first it is going to create a one new pod with a new version. Like this, first it is going to create a new pod with a new version. First it is going to create, and it is going to distribute the traffic for this new pod new pod. Then when this application is working fine, when this pod is up and running, then what it is doing is it is going to down one of the old pod, it is going to down. For example, this pod it is going to down. Then it is going to stop the routing to this pod. Now there are only two pods are up and running. One is with a new version, one is with a old version. When the two pods are up and running, then it is going to create a one more new updated pod with a version 2. It is going to create a pod. Then it is going to start distributing the traffic for this. Then when this new pod is up and running, then what it is going to do is it is going to terminate this old pod. Then it is going to stop distribute the traffic to this. Like this, how the rolling update deployment strategy is going to internally it is going to work. Let us understand the manifest file. This is my manifest file where I am using the kind as a deployment, and I am using the namespace called rolling, and then replica set is 2. And here is the main point. Here I am using the strategy type is rolling update. If you remove this one, by default it is going to use the rolling update deployment strategies. If you type, there is no issue. If you remove also, no issue. Now I am going to remove and show. Now the replica set is 2, labels, selectors, all fine. Here is the one more point. I am using the Docker Hub repository one image name, where I have already have some images here with different tags. You can see tag 1, tag 2, tag 3 up to tag 5. In a web app, in a website also, it is going to change from one tag to another tag so that we can understand better. This is what port is 8080. Here I am creating the node port as a service group. Here these are all fine. Now I am just copying this one, and here is this is my master machine. I just connected through the SSH. If I do the ls, you can see there is only one recreate.aml file is available. Now I am going to create a one more file, nano rolling.aml file. I am just copying everything and just paste it here. Control X, save it. Before going to apply, I already created the namespace. I will just show it once. kubectl get ns. You can see rolling namespace is already created. Now I am going to apply this file. For that, kubectl apply /f and the file name. Now it is created successfully. Now I am going to access this application using the worker node public IP. Just take the public IP of the any worker machine. Just copy it and add the node port public IP, node port number. This is the node port. Just copy it and paste it. Click on enter. Now you can see image tag 1 is up and running. If I do refresh also, it is working fine. Now what I am going to do is I am creating the one more terminal with the same machine, so that I can run the what commands in that terminal. I'm just switching to the sudo user. I'm just running the kubectl get pods. Okay, I need to specify the namespace rolling. Yeah, we can see 2 pods are running. Now here also it is running. Now what I'm going to do is I'm going to change the image tag to the 3. For that, nano, I'm just opening that file. Here I'm just changing the tag to the 2. Just save it. Now again I'm going to apply it. Okay, before going to apply here, I'm just running the watch command in another terminal, kubectl get pods slash o wide and slash n rolling. Okay, I need to add a watch command. Okay, now you can see it is not coming out, it is just still there. What are all things it is going to update from old version to new version? It is going to display how internally it is going to changing. Okay, now here I am just clicking on the enter. Now I am going to applying the new tagged image. Just enter. Now here in the background you can see there are some changes is going to happening. Wait for a few minutes. If you open your website, if you refresh, you can see image tag to the 2. Now we can understand that it is rolling, it's got updated to the new version without any downtime. Now I'm going to analyze each prompt how it is going to updating. Okay, I'm just copying everything. Just I'm opening the one notepad. This is my old one, sorry for this. Just paste it. This is the terminal output, right? Now I'm going to explain each thing in detail. You understand that how it is going to update it to the new version. Now I'm going to explain how internally, means I explain my architecture, right? In my architecture I told first it is going to route the traffic to this one, then it is going to, if it is working fine, then it is going to down this pod, like this I explained, right? I want to prove that, right? Just theoretically explaining is not enough. I need to prove that by running some commands. So here is my terminal output from this. I'm just copying once more. You can see, yeah, this is my terminal output. Now first step what I'm going to do is I'm just dividing it. It is going to be in too clumsy, right? Now I'm just dividing it. Divide. Okay, from these two lines you can understand there is two pods are running. One pod with this IP, one pod with this IP, it is running. That's fine. Next step. Okay, yeah, with this I'm going to explain this diagram once more. Okay, we are here. There are two pods. I'm just taking the public IP also for better understanding. Sorry, private IP of the pod. Okay, these are all the two pods which are running in my Kubernetes cluster. These are all and we are going to route the traffic to these two pods. Now this is fine. Okay, next what it is doing, next step is it is in a pending state. I don't know what it is pending. Next step is pending. Now in this step it assign the host machine, means nodes, worker node. It assign which machine you need to create. Okay, again in the 4-step container creating state. Next it is running. What it is, this pod, this is different pod, right? Just now it's created. This pod with the new version it's created. Now up to here we have 3 pods. You can see 82, 82, 2.82, 1.82, here 2.83. New pod with the updated version it's created. As my architecture tell, it's created a new pod with this private IP with the new version. In new version it's created. This is what fine, and it's route the traffic to this one also. This is what happening up to now. This is fine, right? Now the next step is it is terminating. What it is terminating? 2.82. 2.82 is this one. In this example, this one it start terminating. This pod it is start terminating, not yet done. Okay, here it's terminating. Here also again it's still terminating. This command, this prompt is for old pod. This is old pod terminating. It's assigned this pod to terminate, to remove. In the next step, it start creating one more pod. See, pod it is in a pending state. Pending state, container creating, again running. In this step, if I want to tell, it's terminated one pod and it's created a one pod with a new version. Container creation 1.83. See, 1.83. New pods got created. Now the old pod is went down and the new pod is just created with this IP. Okay. Now it's route traffic. It is stop routing the traffic to this one and it start routing traffic to the new pod. This is okay. Okay, this is what up to this prompt we can understand. Okay, now here in this pod we just deleted, it's got deleted one pod and it's created a new pod with the updated version. Again here it's a terminating what? 10.1.82. 1.82. This pod it is going to start terminating. This pod means this pod. It is start terminating. Terminated. It's got terminated. Here the error message, because I have some issue in that in that image, so it is showing the error message. You can leave this one. If you executed proper image, you will not get this error message. I'm just deleting this one. Now it is deleting the old pod. Here terminating pod 2. Okay, again it's stop sending traffic to the old pod. Again now we successfully updated our application from old version to the new version. I hope this video is helpful for you. If you found this video helpful, please don't forget to like and subscribe to my channel so that it gives me a motivation to help learners for a better understanding the concept. Thank you. Bye bye. See you in a next video. Okay, one thing, actually I forgot the question itself. What is rolling update? What is rolling update? Okay, I need to delete this one. Yeah, simple, right? Rolling update is a deployment strategy. Okay, that everyone know. Rolling update is a deployment strategy that updates an application step by step. This is the main point. Step by step means here you can see the lot of definition regarding the rolling update. I hope if you understand the concept, if you understand this diagram, how it is going to distribute the traffic and how it is going to terminating the old pods, when it is going to terminate, you can understand any definitions in the from the internet. So it's going to deployment strategy updates the application by step. You can see first it's created, one deleted, again one created, again deleted. It's going to be step by step without affecting the end users. It is going to updating to the new version. If I want to check the definition from the internet, this is the Kubernetes official document. Here if I want to explain, here is the main point. A rolling update allows development update to take place with a zero downtime. It's done this by incremental Incremental replacing the current pods with the new pods. Incremental replacing means we can call step by step. There are some few related words regarding that. Okay, I hope. Thank you. Bye bye. See you.